Okay, that makes it 12, and I'm going to crack right on because I think we've only got 45 minutes. I didn't realize I was the last session of the GLA Summit, so I feel super privileged to be wrapping this up. Thank you to the organizers for giving me the opportunity, and yeah, let's get straight in. As you can see from the title, this is a love letter to LabVIEW, but it's a bit of a bait and switch. I'm not actually going to say any poetry, or there's no letters involved. What it really is, just a friendly reminder of all the cool stuff about LabVIEW. So a bit about me, for those that don't know you. My name is Neil Pate. I'm a LabVIEW champion and architect and embedded systems developer, the CLD, whatever that one is. This year is actually 20 years that I've been working with LabVIEW. My first version was 7.0, it's Express VIs, and then I actually went down to 6. It was at 6.1 a bit later. So I've spent pretty much my whole career making stuff with LabVIEW, and yeah, I'm a big fan. So let's see where we get to. I've timed this presentation a few times, but it has quite a large standard deviation. Okay, so I'm going to keep it on the time, and I'm going to finish in time, but I may start rushing towards the end. Depends on how much I ramble. Great, yeah, so just one last thing about me. I currently work at Philips here in Eindhoven in the Netherlands, where I'm part of the test and verification engineering team. I'm the LabVIEW team lead and tech lead for a bunch of our frameworks. So yeah, let's get straight in. I'm happy to stop at any time for questions. This is just a super friendly session, so we can break it up as we see fit. Okay, so this may or may not be like your career, but it's all smiling faces after graduation, and you thought, you know what, I'm ready to conquer the world, and this is what I'm going to do in my first job. I'm gonna just make these amazing things, and you've just got these great ideas, and then on day 0 you arrive at work, and your manager says to you, by the way, here's the equipment you're working on. We'd like you to automate it, and here's what you have to use to automate it. Hopefully not LabVIEW 2. As I said, mine was LabVIEW 7. But yeah, we came here by accident, most of us, I guess, but we stayed here on purpose. And that's the kind of message I want to get across is why did we stay? Let's take some time to remind ourselves. And in one sentence, it's because LabVIEW is great. Recently, I've done a lot of moaning about LabVIEW personally. I thought I were taking things in the wrong direction sometimes, and I got a bit despondent. At one point, I just said I'm not going to do any more LabVIEW, and I spent a few years doing Unity. But I've actually kind of come back, and I'm happy I'm back, and I'm happy that LabVIEW is a part of my life, just because it's so fantastic. So let's remind ourselves why. So let's get the first obvious one out the way, is that we all love data flow, right? I'm not going to spend too long talking about this. Everybody knows it. There's no variables. I don't have to try and come up with a variable name for this wire, like what was it, sensor3 times sensor4, or things like that. We just love it. We love data flow. It's a great concept. Why it doesn't actually take very long to understand. And once you've got the core concepts, so much just falls into place. So much falls into place, including things like this. So you've probably seen this picture a bunch of times. I think I stole it from the forums. If I'm not mistaken, Sam posted it on the NI forum, I think in like 2010 and 2011. And most people use this picture to show how bad LabVIEW is. They say, look at this garbage you can make. It's clearly rubbish. Like that's normally the sentiment that goes along with this kind of picture. And I want to flip that around. I want to say, actually, you know what? This created value for some company. The fact that the software got to this point meant that it lived, it was alive, it had it did some stuff. All right, it clearly started off as a blank block diagram, probably a developer who was new to LabVIEW, he learned it, and they got this far. Right, they did it, and I believe, if I remember the forum post correctly, Sam was asked to do some refactoring. So in fact, it still had value, like years later. And of course, it's garbage code. We look at it and we say, that's terrible code. And you're sure, you would never write code like that now. You would never start and say, I'm going to make something that looks like that. But this thing, probably built into an executable just fine. It might have had quite a pretty front panel. Nobody knows. My point is, like, let's focus on the good here. And the thing is, this thing probably ran, right? Like, I'm actually not such a hater of this. And some of the other things jump out of that. Like, immediately I can see structure in the code. Like, again, it's bad code, but there's a for loop, right? Like, it's LabVIEW makes these things easy for us. Imagine if that was badly written C code with braces that weren't matched up nicely, and you're trying to hunt around and figure out what's the structure, where does this loop start and stop. With LabVIEW, we just kind of get that for free. Like, it's hard to rank features, but the scope of diagrams and being able to see where things start and stop is, for me, just so powerful. Now, I mean, I love it to bits, and I would just miss it if they took it away from us. And certainly, like, these days, I do programming in other languages like Rust and Python, and I do miss the obvious visual nature of the boundaries and the scope of structures. Sure, Visual Studio these days, when I use Python, I get little hints in the editor, but I don't think anything is quite as powerful as a for loop in LabVIEW. LabVIEW is a visual language, right? So fundamentally, we're looking at it with our eyes, and it straight away conveys stuff to us that allows us to reason about the code. And for me, one of the most powerful things is the type system that's represented with colors and with physical representations. So on the left, these were all the primitives I could think of. I did go through, might have missed a few, but they're instantly recognizable to anybody who's done any LabVIEW. Like the fact that integers are blue and floating point numbers are orange. Like, you can never take that away from me. We can glance at a piece of code and start reasoning about it straight away, just by looking at the color of the wire, or the shape of the wire. Like, if we're consistent, then references are all these funny colors, and then we know we can do things with them. If we follow the rules of data flow, we know we can branch certain wires, and references give us the ability to operate on data kind of in parallel, or if we branch a constant, a bi-value type wire, then we know we've got two copies of effectively two different pieces of data. I love it. I just love I admit it took me a while to get over the fact that when they changed the error cluster, I mean, I'm going back a bit now, but I believe this used to be like a pink as well. I inherited just the regular cluster type format. And I guess this is not really a primitive. It shouldn't be in the side. It's just a cluster. But again, it's that visual representation which instantly comes to us. And then we get things like the patterns on the wires. So sets and classes, they have the ability to, or at least classes have the ability to define a pattern. And sets have this little zigzag, which I guess is kind of the best they could do with the limited number of pixels. But it's all great. And then we get things like scalars versus vectors. In LabVIEW terms, it's a single value versus an array. And as we add the dimensions, so the wire gets a bit fatter. And again, like, I think you should probably stop at 2. If you're going to 3 and 4, well, maybe you should reconsider some of your design decisions, but that's okay. But again, instantly recognizable when I'm reading code. And as we know, we spend way more time reading code than writing code, like way, way, way more time. So we should optimize it for the use case where it's Monday morning and you've come in and you can't remember what you did on a Friday beforehand. So we want to make it easy to remember what we did. And just the visual hints in the editor are really, really powerful. Okay, I'm going to jump around a bit in order. I'm going to jump to the front panel now. I'll get back to block diagram a bit later. But if you think about it, the front panel is just such a good idea. right? I kind of wish it was optional in modern LabVIEW. I think that might make our lives simpler. But the front panel, when I think about sub-VIs, so I don't mean like your top-level GUI. We're not going to talk about that. I don't think LabVIEW is particularly compelling tool to use anymore for designing my top-level GUI. I think it's quite hard. And actually, I'm looking forward to rewatching is it Hunter's presentation from last night on the front panel. It was a bit too late for me, my time, but maybe I'm going to get some tips and tricks for that. But I mean more for like in other languages, what would just be a function call or a method call. You know, that for us is what we would say is a sub-VI. Sub-VI is just a VI, so you get a front panel, and that's where you can throw your controls down and the things that make your life easier as a developer. So like the graph indicator, like I love this thing to bits, right? It looks like it's from like 1997, and it probably is, but that means it just works well, right? It hasn't needed to change too much. I don't need the VI to be runnable. I can change scaling. I can zoom in. I can pan around. I can hide channels. I can do all the stuff I need to. Zero programming required. And again, this is like don't think of this as 2024. This stuff was there when I started in 2004. So again, try and put that into context. Actually, most of this stuff has been around from the beginning. So think about how, like, try and put yourself back 20 or 30 years and think about how cutting edge and just how fantastic these concepts were. And the front panel is really one of them. Like, I think it is a really good idea. Okay, back to the block diagram. And in fact, this is probably where I'm going to spend most of my time, is on the block diagram. But the event structure, like the event structure is fantastic. And I had the privilege of starting with LabVIEW 7, which did have the event structure. And then in my next job, I had to go to LabVIEW 6.1, which didn't have the event structure. And I didn't know this at the time. And I looked at some code. I'm like, well, why is this engineer doing all this polling of these controls? Like everywhere it's polled. Like, well, what's this person doing? Are they an idiot? That was my thought. So I thought, I'm going to fix all this code and introduce an event structure. But then I couldn't find the event structure anywhere. At that point, I realized that it had been introduced around about LabVIEW 7 time. And actually, it hasn't really changed much since then. So it's, I would say the design is pretty good, right? It's not perfect, but it certainly does the job for a lot of use cases. The ability to configure your user interface type events, so like your button clicks and your mouse drags and the things that you as a user interacts with. And then for the same structure, to be able to configure it to handle user events, which by the way, I do have to say, that's a very badly named thing. Like to have user interface events and then user events which aren't the same thing. And of course, I'm talking about the ones where you use the dynamic terminal and the things in the triangular brackets. I guess I prefer to call them dynamic events. But getting that out the way, I think adding events into the block diagram or data flow in the way they've captured it is really nice. And I'm really happy with using events in general. And of course, we get the benefit that, and for some time now, this actually works on RT. So you can use all events on RT if you want to, assuming you have the embedded user interface. Then you get user interface events, so things like button clicks. And of course, you get the dynamic events, which allows you to have a multi-loop structure. So again, that's pretty much what I use it for: message passing or broadcasting of data, effectively sharing data or state across multiple loops. Okay, back on the block diagram, and another one of my favorite features, and in fact, pretty much this whole presentation is my favorite features. And again, it's got to be said, these are the things I find cool. At the end, I'm going to list a whole bunch of other things which didn't quite make the cut, but other people might prioritize, right? Clearly, different people use LabVIEW in different ways, so everyone's got an opinion. This is just my opinion of the things that are cool. But I remember in 2004, when I started to use LabVIEW, and I first discovered this auto-indexing, I was blown away. I hadn't seen anything like it. I came from a C++ background, and I don't think C++ at that point had auto iteration over collections and things like that. I mean, they do now. Most languages have this now. But I love the ability to auto-index over arrays. It's just fantastic. That and the built-in loop iteration counter. So the I, which is always there. Use it, don't use it. It's there. You can hide it away. If you're feeling particularly creative, you can take it and you can put it up next to the N, and you can spell NI, and you can do also kind of fun stuff like that. You can hide it behind the side of the for loop if you want to. But these are all great. Like they give us freedom and flexibility. And again, in the context of 2004, this is 20-year-old ideas, even older. And then we have the ability to collect data on the outside of the loop. So where we can do things like changing the tunnel mode, where we can pick the last value, where sometimes that's all you care about, or where we index it, which turns it into an array of some sorts, or the new option to concatenate. I don't use this one too often, but that's useful for a string where you don't want a higher dimension of the data, you just want more elements in the same thing. And then the handy little conditional, which was added, I forget, someone can help me out when this was added, maybe like 10 or 15 years ago. But this is pretty cool. It gives you this little green Boolean terminal, which you can wire in. Yeah, maybe it's something like that. That feels about right. At first, I didn't use this, but now it's really handy if you recognize the pattern. Really handy. One thing I didn't say up front is all these code snippets. I haven't tried to make the world's most beautiful code or the world's most sensible code. I'm just trying to show some examples. So again, like hopefully in your production code, you would never have random constants like 65 and 75, which just happen to be, that's the ASCII A. But yeah, it's all this convenience that's right there for us as a developer to use and quite accessible. Like once you know about the right-click menu, then it's there and easy to use. While we're talking about auto-indexing, I love the auto-indexing over higher dimensions of data. So if I have a 2D array of data, hopefully I've been sensible about this, and I've put all my channels as rows, and I'm sure everybody does this, because then when we auto-index over the 2D array, we get a channel at a time, which is effectively a row of the 2D array, and then we can do stuff to it. And I guess in memory, again, I don't exactly know how LabVIEW works under the hood, but if your rows are contiguous in memory, that might be a faster operation as well. I meant to change the slide. That I was going to say, if your data is the other around, you could insert the handy transpose function, which I think is just an instruction to the compiler that your data is kind of 90 degrees flipped. But again, that might be a little bit slower if the compiler has to then go and pick memory elements that aren't contiguous. So again, loop auto-indexing, just a great idea and really sensible to use. So here's the first one that might be a bit contentious, and that's the talk of express VIs. Express VIs came out, again, in the first version of LabVIEW that I use, so LabVIEW 7.0. And I don't use them very much, except for this one, the DAC Assistant Express VI, which I think is actually quite a nice little thing to use. And for those who don't know about it, it's under the measurements or instrumentation palettes. I never remember which one. I always click the wrong one. It looks like this, and when you drop it down, it gives you a little wizard that shows you the devices connected to your PC. You can pick a few channels, very quickly run a test to sample some data. So this is, I actually have a simulated DAC on my PC. So it's like simulated data, but you can configure your settings, and then very quickly you can generate some code. So that's typically what I use Express VIs for, is I use them as a convenient way to quickly get me up and running. Especially when I'm not familiar with the API. So for example, analog input now, I'm pretty comfortable with this. I could probably write this code without needing the ExpressVI. But say you gave me a sensor that had like TEDS calibration built into it, or some counter timer stuff, or something weird that I haven't used, then I would use this ExpressVI. I would use it. I would drop it down. I would unpick it. I will unpack it, and then use the code. And the nice thing about this is, again, I have no evidence to actually back this up, but I believe that the ExpressVIs was NI's big push to kind of get scripting polished up, because it would have been used inside, right? So these ExpressVIs are all scripted under the hood. It uses LabVIEW scripting, and it was a few years later that scripting was made public. But I guess the fact that these exist means that NI were using them internally to make, and the APIs got robustified, or I guess they were dogfooding with it. So again, I'm grateful for all of these things. Speaking about hardware, I think it's pretty clear that a lot of us use NI hardware and LabVIEW together. And again, like I don't know my history exactly right, but I think if I remember correctly, LabVIEW was created to solve a problem of it was hard to talk to the original DAC or GPIB boards. I think they were GPIB boards. So the original founders came up with this idea. They came up with LabVIEW to allow them to program and to make it easy for engineers to use the DAC boards or the GPIB. And over time, this kind of partnership's just grown up together. So we all probably use LabVIEW to talk to NI hardware. I think we're all pretty comfortable with it. Everything from simple USB DACs to giant PXI chassis, or simple RT controllers with FPGA, complicated ones, everything in between. It just works so well together. The ecosystem is designed to work well together. And like most of us can, if you gave us a piece of NI hardware, we could get a measurement up and running within probably 10 or 15 minutes if we had to. Based on the wizards and the tools, we could start getting signals on the front panel and get some display. So it's just that rapid iteration until that feel-good feeling, right? Everybody loves seeing the real signal in real time on the display. Even if it's just an LED turning on and off, or being able to read a digital input, or doing something a bit more complicated, there's that little endorphin boost that we get. And the combination of LabVIEW and NI hardware just goes so well together. I guess it's like peanut butter and jelly. Okay, just checking the chat. Tim says that conditional autocomplete was 2012. Okay. Gosh, that's 12 years ago. That's quite a long time. Okay, but then clearly a lot of us use non-NI hardware as well. And this is where LabVIEW is actually also super flexible. And I guess almost every instrument these days has some kind of VESA interface or Ethernet or serial port or something that we can control and talk to it with. Sorry, I seem to have picked up some kind of weird chesty thing. But LabVIEW makes this easy for us again. It just works so well together. And the same principles apply, is that we're able to get up and running and have some instrumental machine control really quickly with LabVIEW. So a massive bonus there. Okay, this is not a scientific slide, but I'm going to put it in anyway. Another reason that LabVIEW and I have gotten on so well is that for me, it's fast enough. So it's not going to break any speed records. It's not the fastest language in the world. You wouldn't try and do everything you can in LabVIEW, but at the same time, it's no slouch either. This is a graph I got off the internet, so trust its accuracy as much as you want to, but I don't think it's super important. It effectively ranks languages based on some artificial test. And the yellow box is where I would guesstimate LabVIEW is, kind of somewhere between C# and C++, somewhere in there. And for most of our applications, that's fast enough. So again, it's the engineering trade-off of who cares if I'm not going to spend another 2 months trying to optimize the crap out of an algorithm when I don't need to. And LabVIEW helps me to do that. It typically compiles down to a sensible enough format. I think there's a virtual machine in the way. I'm not exactly sure how the internals all work. But the bottom line is it's fast enough, and that makes me happy. I haven't come across too many applications where I've thought, actually, LabVIEW is my bottleneck here. If you use sensible programming techniques and you have multiple cores and you partition your system sensibly with different processes, I think most of the time it's the design of your system that's the bottleneck, and not actually the speed of your LabVIEW code. I mean, quite often on a modern PXI chassis, even when you're talking to all the DAC cards at the same time, CPU is not really doing very much. So it's good enough, right? And that's typically what I'm aiming for. Okay, another favorite feature. I love pasting random things on the block diagram. I just can't get enough of this. I think it's a superpower that LabVIEW has. It just helps me so much in my day-to-day work. So this particular screenshot is from some code from my 3D renderer. And in there, I've pasted a screenshot from Notepad of the file format I'm trying to use. I've pasted some settings that I need to put in Blender when I export an object. And I've pasted a screenshot from Blender reminding me which corners of my primitive are shaded in a certain thing. The sky's the limit, right? It's really up to you on what you do. And the nice thing is that these are all editor time penalties, right? If I paste something in here, sure, the VI gets a bit bigger, but then, when I come to build the code, pretty sure LabVIEW strips away all this stuff, and my final version of the code, or even the code that's running in the editor, that doesn't matter. It doesn't matter that I've got a 500 kilobyte JPEG pasted into the VI. Modern PCs don't really care about this kind of stuff. Imagine trying to paste a picture into your Python code. You'd have to use ASCII art or something, or you'd have to try and describe it. And again, it's just a feature I haven't come across in too many other languages, and I think it's just super powerful. And I would be annoyed if they took it away. No one's suggesting that, though, by the way. I use this a lot also when I'm dealing with DLLs. So I like to, maybe I'm an idiot, but I like to hand import DLLs. I don't trust the import wizard very much. So I pretty much do it method by method as I'm building out a wrapper for an API or for a DLL. And there I really like to paste in some content from the wiki page or some documentation on how the DLL works, how that method works. So guys, paste random things in the block diagram. It's fantastic. I'm just checking out some of the comments here. I see Tim's mentioned parallelism. Well, that's fortuitous, because here we go. Next topic: simple and intuitive parallelism or concurrency. For the sake of this discussion, I'm not really going to make a difference between parallelism and concurrency. There is a difference, but to the actual end user, us as developers, I'm not sure often it's that important. The fact is, we want things to happen at the same time. Where time is it's a relative thing. Obviously, we're not talking nanosecond precision in terms of things happening at the same time. But I guess what I'm trying to say is we don't want things to block. And so quite early on in your LabVIEW journey, you come across a producer-consumer type architecture, the queued message handler, and many examples that ship with LabVIEW. DQMH is all of those based. Once you've got your head around that, it's just such a powerful concept that doesn't really require that much thinking about. Almost intuitively, after 6 months to a year of using LabVIEW, you'll understand how to share data between two loops. You just kind of do it, and we don't have to worry about spinning up threads or multi-cores or async processes and all other things in other languages. I have to mark in Rust or Python, I have to mark a method as async if I plan on using it asynchronously. And in LabVIEW, we typically just don't worry about this stuff. Sure, if you need a VI to be re-entrant, you have to change some things. But LabVIEW really does make it simple to get started. And that's often half the battle, is allowing you the freedom to take your first steps. And I think LabVIEW does that really well. It doesn't get in your way when you experimenting with this kind of stuff. It's very sympathetic. Like I think the original slogan was at one point in the 90s or noughties, programming not required. Certainly with asynchronous stuff, you've got to do a bit of thinking, but we don't necessarily have to do that much programming. And I really appreciate LabVIEW's approach to it. Again, that naturally flows from data flow. Okay, on to the next one. I think a lot of us probably never used any other languages, so never needed to struggle with these kind of things. But if you came from a C or C++ background, or one of the older ones, you had to, whenever you wanted to use a data structure, you had to kind of ask for the memory, unless it was some simple data type. So you had to do things like mallocs, and you had to do things like freeze at the end. Otherwise, you would leak data, or you had to have constructors and destructors for your objects. And you had to worry about all this stuff. And typically with LabVIEW, we don't spend our time thinking about these things. Like I guess the only time in LabVIEW we think about memory is on that one day when finally you screw it up and you get the little dialog box saying LabVIEW does not have enough memory to continue with something. And you don't even have an option to say yes or no. I think that's game over. And it happens to us. And it's typically because you've got something wrong with one of the input terminals on an array, and you flipped it around, and your 2D array or 3D array is much bigger than you expect. But typically, with a modern PC, with enough RAM, I'm using 64-bit LabVIEW now, we just don't need to worry about these things. LabVIEW does a good enough job. And again, that's kind of the key with a lot of these things. It really does a good enough job to free me up from worrying about the nuances of these things. Again, you wouldn't write an operating system in LabVIEW, but I would write a big test and measurement type system because it's good enough. Okay, another favorite feature of mine, and I use this all the time, is LabVIEW is fantastic for debugging. It had the tools that are built in, I feel, are just so sympathetic to debugging the kind of problems that we have. Like the abort button, I think it's fantastic. And I do this all the time. Like if I'm debugging a complicated system, it can have multiple loops, it can have actors, it can have things going on at the same time. When I finally find the VI that has the problem, so where a bunch of outputs don't match my inputs that I expect, or there's an error generated somewhere, typically what I do is I just hit abort. I literally just hit abort at that point, and all the software gets killed, assuming I haven't got any hardware that I need to worry too much about that's going to hurt somebody, or hopefully I've got safeguards in place. But typically, it's just software. I hit the abort, and then this is my favorite bit, is the sub-VI still open? It's still open, and assuming we're being sensible about this, we're using nice, pure by-value data types, so my inputs are still there. So I can run the VI again. And that's it. Like, it's just, it sounds so dumb, but it's just so convenient. I can run the VI again with the same set of inputs that caused the problematic outputs. And in fact, then what I can do is use the run continuously button. And I do this all the time. I turn on retain Y values, I run continuously, and very, very quickly, I can drill down to the problem. I can hover my mouse over a Y to get its value. I can hover the mouse over an array type, and typically what pops up is the size of the array. So here you'll see here I've put down a probe, got the probe thing, but if I didn't put down the probe and I just hovered, I would at least get an indication of how big the array is. And that quite often gives me enough information. I was expecting 1,000 elements, I only got 100. No, I've obviously got something wrong. I was expecting 100 and I got 10 million, something like that. So like the debugging experience in LabVIEW, I think is just really, really I won't say fun to use because, debugging is not necessarily the world's most fun task, but it's probably about as fun as you can get. And I actually really enjoy debugging things in LabVIEW. Okay, I'm not following the chat nearly as well as I can. I just the last comment, Steve, I enjoy debugging. I'm with you on that one. I kind of find it therapeutic. Give me anybody's code and I'll happily debug it. Okay, onto the LabVIEW project, and a feature which is not that uncommon to other languages, but it's access scope and then combined with virtual folders. And I think this is great. Like, I use it all the time. If I make a class, the first thing I do is I make 2 virtual folders, one that I make private, which I call sub-VIs. Sometimes I have a space between the B and the V. Sometimes I don't. So I try and be as consistent as I can. But I do always try and have a public virtual folder called API, where I put the stuff that I can call when I'm outside the class, the public API. And straight away doing that just helps me keep a little bit maintained. And the thing I like about this is the virtual folder structure doesn't necessarily need to mimic the structure on disk. So previously, in fact, I went through a phase where I would try and mimic one-to-one the structure of the project and of the class and the file system. So I would create directories for things like API and sub-VIs. But then I found I was moving things around and it was getting my source code control a bit messed up, or this was maybe even the days before I was even properly using source code control. So now I keep a nice flat class structure, and I use the virtual folder feature within LabVIEW or within the LabVIEW project to organize things nicely. And I must admit, I was quite disappointed in LabVIEW NXG when they told me that they were going to take away virtual folders because we shouldn't need it. There was going to be some kind of filtering. In fact, I was pretty annoyed about this. And it was kind of around about that time that I decided that maybe LabVIEW wasn't for me. It wasn't just that reason. So I'm kind of glad that we don't have to worry about that anymore. And we've still got virtual folders, hopefully for the rest of time. But that combined with access scope, I just think it's a really good idea. Certainly I'm doing some work recently in Python, which doesn't have access scope. It more relies on people to be sensible or to have some kind of conventions in their code where you do underscoring. I'm not sure how keen I am on that, so I see both points of view. But I think I like LabVIEW's way. Okay. Another really powerful feature, which I think a lot of us take for granted, and I don't know how to describe this properly, so I'm just going to try. I've called it visual remembering. And that's like, I can take code from 5 or 10 years ago that I've written in a different structure, and I can quite quickly remind myself the structure of the program. Because I guess my brain was used to the layout. It was like a pictures type thing. I guess like we all know our way to get home, but maybe we don't know how to get there if we looked at a map. I don't know if that's maybe not such a great example. But what I mean is that there's something about the nature of LabVIEW being a picture that really helps me know where things are in my code. Like I can remember that this VI was inside the event structure or something like that. Like it's just, I don't know, it's something about it. Like I just wanted to put it here. That there's something about this that really helps me. And again, as I mentioned, is you spend way more time reading and reasoning about your code than you do writing it. So anything that can help us there is just super useful. You can almost do a whole bunch of this stuff automatically. Like you can drill down into code without even thinking about it. Whereas when I'm working in Visual Studio Code or other things, I find I've got to think a whole bunch harder to find where things are. Maybe it's the 1D versus 2D nature of how code's laid out. I'm not too sure. Okay, perhaps the coolest thing about LabVIEW though is that we get to work on some cool stuff. Like it really do, the whole grand engineering challenges kind of thing, we we're so lucky to get to do this stuff. Like this is our job. Like every now and then I catch myself thinking like, shit, somebody's going to pay me to do this. Like if I'd probably do this for free, like if I didn't have a mortgage, some of these things. And maybe I think we take it for granted how lucky we are to get to work on these cool things. Like I've been super fortunate. I've been exposed to a whole bunch of different industries, and pretty much LabVIEW is used everywhere at its core when you get down to the measurement side or the machine control side of things. And it's fun, right? Like we get to solve some really interesting problems or get to work on some really cool things. Like, at one point I was racing cars around a racetrack, and now I'm saving lives at Philips. We're making machines which will save people's lives. And I recently had a few scans, and I was comfortable to know I was in a Philips machine because LabVIEW somewhere along the line had been used to test some of the products or to develop it. And I just think that really makes me happy. Okay, final slide. We've got 5 minutes left, and I wanted to save some time for questions at the end. So I think our timing's pretty good. I have to apologize. The slide in purple is taken from a presentation a few years ago. I'm obviously not a very good software developer because I didn't put the slide into my source code control and I lost it. I guess I deleted it or whatever, or reformatted the computer. I did everything that I tell people not to do. I did it. So I have a screenshot of my old slide. Why I'm apologizing is because I would definitely edit it. There's certainly people who've popped into my mind recently in the community. I would add to that list of people who've been so helpful to our community. But that's really what, for me, makes our little group so special, is things like this GLA Summit, things like the DevCon, things like the Ducklugs. They're really great. Like, they're really great, and the community and the friendliness, and everyone's just so willing to contribute. Generally give off their time. Like, look at the training initiative that Steve's putting together, and all of these things. Like, it's just fantastic. And I really encourage people to get involved as much as they can to really help out, because it's again one of our strengths as our community is small, but that means we can be really tight knit. And it's just, again, fantastic. Okay, last slide. I missed some things. I put some things down here, which for me, we could have spent heaps of time talking about. There's definitely things there, favorite features. I mean, shift registers, love it to bits. Plug diagram, Zoom, haven't had much chance to use it too much. LabVIEW channels, I don't use myself, but I think when you're getting started, it's a really good introduction to talking between loops. I mean, VIMs, I like the wires. Like, perfectly. Like, I mean, again, everyone's got their little thing, and that's what makes it awesome is we all have our own opinions. So have I missed any obvious ones here in the list? Because if I do update the slide, sets maps, yeah, good. I do. Maybe I'm getting my head around them a little bit because I'm still used to having arrays with other arrays for names and things like that. So set maps are good. FPGA, absolutely. Interfaces, yeah. Quick drop, agreed. Yeah. Also indexing. Okay. Does anyone have any questions? We've got a couple of minutes left before the wrap up. And maybe in the last few minutes again, I'd like to just thank everybody, the organizers of the summit. I think is such a great initiative. And thank you for taking the time to listen to my presentation and listening to me jabber on about LabVIEW, but I guess that's why we're all here. Thank you.